Hello, my name is Kyle and I'll be introducing you to Honey Potion, an open source project that allows us to harness the power of eBPF with the easiness of writing Elixir code. In today's guide, I'll show you how to make a Linux system call counter, just like this one, with just a few lines of code. If that interests you, let's get started. If you haven't set up your environment yet, follow our other video for a guide on how to use Honey Potion. Assuming that you have honey in your mix.ex just like this, we can start writing our file. Let's place it inside the lib folder and give it the name of countsyscalls.ex. With that done, let's set up the Honey Potion boilerplate by adding the lines showed in the Honey Potion guide. This one creates our module, countsyscalls. You can think of modules in Elixir like classes. After that, we add this line to include Honey Potion in our project. Next up, we do this line. This line, which has tracepoint row syscalls sysenter, defines the trigger that eBPF will use to call our program. If you are new to eBPF, you might still not know what the trigger is, but don't worry, it's quite simple. When the Linux operating system does a system call, he leaves a message saying what call was made and of what type. That message can be noticed and be used to trigger the execution of eBPF programs. Here we will use sysenter because it's sort of like a father trigger, where many different calls also trigger it before doing their own operations. Finally, we define a main method. Please note the name of the method is main. That is because Honey Potion translates what is inside the main method as the output program. So be sure to call your method the same way or Honey will complain. To keep information in between different BPF triggers and to be able to access it, we need a data structure. For eBPF, that data structure is called a map. We can define a map using Honey Potion like this. First, we use the define map macro to show that we want to create a map. We then give it a name and define its type and size. This map type means that it will behave equally to an array of max entries, which we defined as 335. To make our life simpler in the future, we will be formatting our define map macro like this. This is because later on we might be adding a few more things inside this section. Great, now we can start writing code inside the main function. In the first line, we will be taking the ID of the ctx argument. Ctx is the argument of the main function and is a structure that the system call passes to us. In the case of sysenter trigger, the ID section stores an integer-like number that represents what type of call is being done. You can find out what integer is equal to what call online. I'll leave a site that shows that in the description of this video. Great! Now that we know what type of call is being done by this ID, we can access the map and grab the value with the index of the ID and increment it by 1 and put it back into the map. Effectively, we are keeping a counter of the system call in the index of its ID. Currently, our program is ready, but first let's go again step by step. First, we have imported Honey. Then we created a map called countsyscalls invoked, gave it a type and the amount of entries that we are allowing. We defined our trigger to be systementer because we want to be called by many different types of triggers. Then we have the sysenter trigger. Systementer was chosen because it's a father trigger and is called when many other system calls are done. After that, we are taking the ID that is given to us by sysenter in the ctx argument. We are looking into the map, that index of the ID, and we are updating that index by the value that was inside of it plus 1. Now, let's try and compile our program. To compile our program, first we have to make sure that Mix has all of its dependencies. Now that we know that Mix has Honey Potion, we can do a mix compile -- force to make sure that it will be compiling our program. Now that our program is compiled, we can find it in the lib binary folder from the root directory. You can see it right there. When running eBPF programs, make sure to run it with administrator privileges, or else it won't be able to enter the kernel. By giving it our password, now we have a program, and it's working, but we can't yet see anything. That is because we still haven't asked our program to print out the results that we get. Even though it's working, we cannot see it. However, this is not a problem because Honey Potion has a way to print out the elements of a map, so let's do that right away. By going back to our program and adding in print true and then print element as a list of tuples where the first element is the name that you want to print and the second is the ID or index of the map that you wish to print, we will have a print of the name followed by the value that is inside the map. Let's do as before and compile our program. So to do that we go back to directories and we run our mix command. Great, now we can go back into library bin and inside it we can run our program once more. And there you can see that our system call counter is working. Even if we, for example, create a new process and kill it, you can notice that the system kill is updated, so all of its processes are working fine. However, you may notice that it still looks a bit different from the original one. That is because in the original one, I have made it a bit nicer looking in the prints that are done. To manage that, all you need to do is just change a bit how it's done. Here, you can see how countsyscalls is implemented in our repository. You can find it in the examples folder. So, first we define a print list with a bit of a few nicer names, where we can define, for example, that it's a system call of type enter read with the key 0, of the quantity of, then it will be printed with the quantity. We repeat that for all of the elements that we are interested in. We define the map as before and the rest of the program is exactly equal. So if we go ahead and run this example by again going back to directories, then compiling our program, then going back to libbin, we can execute it again and you will see that it's exactly like it was before. Thank you very much for watching and I hope to see you in the next Honey Potion Guide video.